What's going on, y'all? So we are going to add and subtract rationals in this video, and let's get started. So the first example I'm going to do is not quite rationals, but something close, something fractions. We're just going to add fractions. So the first step is to go ahead and find the least common denominator. And there's a couple ways to do this, but I'm going to kind of do it in a way that you might not have seen before. So what I'm going to do is I'm going to rewrite the denominator into its prime factorization. You can get that using the tree thing. But, so example like 4 would be 2 times 2, 6 would be 2 times 3, and that's what I'm going to write at the bottom. So we're going to rewrite this, so 3 over 2 times 2, and then plus 1 over 2 times 3. You can say that these are the factors of these numbers. So now, to find the least common denominator, you're just going to kind of multiply the top and bottom by what they're missing. So for example, we have some 2's here, but if you take a look, the second fraction actually has a 3. So we're actually going to multiply the top and bottom of the first one by a 3. Because that's kind of what it's missing, what it doesn't have from the other one. And then for the second fraction, I'm actually just going to multiply the top and bottom by 2, because it already has a 2 and it has a 3, but it's missing that second 2. So I'm going to multiply the top by 2 and the bottom by 2. So let's see what this gets us. Well, the top, I have 9, and then at the bottom, I'm just going to leave this in the prime factored form. And then the top, I have 1 times 2, and then the bottom is 2 times 2 times 3. So now that the denominators are the same, well, I can actually just add the numerators, and then I'm just going to go ahead and multiply this. So 2 times 2 is 4, times 3, it's 12. So this is the process, exactly the process that we're going to do whenever we have variables. It's going to already be in this form, the factored form, and you're just going to have to find the least common denominator by multiplying the top and bottom of each fraction by what's missing, what it doesn't have that other ones have. So let's go ahead and go to an example. So here is an example. So thankfully for us, we don't have to factor anything, even though we will have to in the next example. But in this one, we don't. So in the first one, we have x minus 2, and we need to get this to have an x plus 3. So what we can do is we can just multiply the top and bottom by x plus 3. And then we have x plus 1 at the top, and then over x minus 2. And then for the second one, well, it has an x plus 3, but it doesn't have an x minus 2, so I can just multiply this by x minus 2 over x minus 2. Great, so now I can just combine like terms. I'm going to have to FOIL the top. You can go ahead and leave the bottom in factored form, that's a-okay. So I'm going to FOIL the top, so this is x squared plus 4x plus 3, and then it's going to be plus x minus 2, and then over x minus 2 times x plus 3. So let's go ahead and combine like terms, and then I'll get x squared plus 5x, and then plus 1. You can't factor that, so there's no need to worry about it. X minus 2, and then x plus 3. And this would be a perfectly acceptable answer, except that you need to make sure that you have to exclude values from your domain. So remember, you can't divide by 0, so any values that make any denominator 0 is not going to be part of your domain. So x cannot be equal to 2 or negative 3 in this case, because if I plug those numbers in, I would be dividing by 0. So let's go ahead and go to the next example. So here is the next example. First thing you're going to want to do is factor everything first. So I should have taught you about FEFBE by now. And yeah, you got to FEFBE it. So the top, it's a difference of cubes. So you should have something like this, 4x squared minus 6x plus 9. And then at the bottom here, we're going to have 2x plus 3, and then that times x plus 1, I believe, minus 3x minus 1, and then x times x plus 1. So we factored everything first. Now let's go ahead and simplify. So 2x plus 3 is that will cancel out. But now let's see, we have to find the least common denominator. So the first one actually has x plus 1 already, but it's missing an x. So I'm going to multiply the top and bottom by just x. And this one already has an x plus 1, so we don't actually need to multiply the second one by anything. So let's go ahead and see what we're going to get. So let's go ahead and FOIL this out, or not FOIL, let's distribute it out. So this will be 4x cubed minus 6x squared plus 9x over x times x plus 1. And we need to subtract 3x minus 1. So remember, you have to distribute your subtraction. So it's actually going to be minus 3x and then plus 1. So let's go ahead and write this neater and combine these like terms. So 4x cubed minus 6x squared plus 6x plus 1. And then this is going to be all over x plus 1 times x. So we're not quite done yet. I should inbox this actually. We need to make sure that we include our excluded values. So x cannot be equal to 0, -1, and also it can't be equal to this either. It can't be equal to, if you cancel any terms out, you have to make sure you exclude that from your domain as well. Remember, that would basically be a hole in your graph. So this would be not equal to 3/2 as well. And this would be your answer. Alright, so that's going to be it for this video. I know it's 2 short examples, but hopefully that helps you if you were confused. So, bye!